Hello again. In this video, I'm going to go over this homework problem from 2.2. So I'm just going to read through the problem and show you how you can work it out. So it says, use the graph of g and the figure to find the following values if they exist. If a limit does not exist, explain why. Okay, so they're referring to the graph of g of x over here. So the first thing we're supposed to find is g evaluated at 2. In other words, if I input a 2 into the function, we're supposed to find the output. Now the input values are on the x-axis and the output values are on the y-axis. So x equal to 2, that would be my input value. When I plug a 2 in, you can see that the ordered pair is 2, 4. The y value that comes out is a 4 because this is at 2, 4. Okay, so if I plug a 2 in to the function, it appears that I get a 4 out. So g of 2, g evaluated at 2, is 4. Okay, part B, we're supposed to find the limit as x approaches 2 from the negative side of g of x. Okay, so 2 is right here. If we approach it from the negative side, we have to plug in x values over here. And we're supposed to determine what the output values or the y values are getting closer to as that happens. So for example, if I were to plug in a 1, the y value that comes out is positive 1. If I get closer to 2, I might plug in 1.5, and the y value that comes out appears to be 1.5. And so you can see the closer I get, like if I go to 1.9 for x, the y value that comes out is 1.9. So what y value am I getting closer to as x gets closer to 2 from the negative side? Well, the y value that I'm getting closer to appears to be 2 itself. And you can see that because if I plug in x equals 1, I get a 1 out. If I plug in 1.5, I get 1.5 out. If I plug in 1.9, I get 1.9 out. You can see that these y values are creeping up and getting closer to 2. Okay, so this limit here, as x approaches 2 from the negative side, this limit appears to be 2. Okay, so that's part B. Okay, part C, we're supposed to find the limit as x approaches 2 from the positive side of g of x. Okay, so from the positive side of 2, you'd be plugging in x values over here. Again, 2 is right here, and so we've got to plug in values over here. So let's say you plug in 2.9. The y value that comes out in this case would be 4. And the closer that you get, like if I were to plug in 2.5, I still get a 4 out. Yeah, 2.5, right? If I plug 2.5 in, I get a 4 out. If I get closer, like 2.1, I still get a 4 out. And so as I get closer to 2 from the positive side, the y values that I'm getting out up here are 4. And so this limit here would be 4. Okay, so that's part C. And then part D, we're supposed to find the limit as x approaches 2 from both sides of from both sides of the function g of x. So this is called a two-sided limit, and you can tell that it's a two-sided limit because it doesn't have a superscript. Like this one has a superscript of negative, which means it's approaching from one side, right? Just the negative side, whereas this superscript means it's approaching from the positive side. If it doesn't have a superscript, then it's called a two-sided limit. And what you have to do is you have to evaluate the limit from the negative side and the positive side. If those numbers are the same, then that's the two-sided limit. If these are different, the left side and the right side, right, the positive side, the negative side and the positive side limit, if those are different numbers, then this two-sided limit does not exist. Well, in this case, we got two different numbers, right? From the negative side of 2, the limit was positive 2, and from the positive side of 2, it was 4. And since these are two different numbers, then the two-sided limit does not exist. Okay, so the answer is B. Okay, moving on to E, find G evaluated at 3 So if you were to plug a 3 in to the function, it looks like you get a 2 out. So g of 3 is 2. For f, we're supposed to find the limit as x approaches 3 from the negative side. So 3 is right here. If you approach it from the negative side, you have to plug in x values over here. And so let's say you plug in like 2. When you plug a 2 in, you get a 4 out. If you plug in a 2.5, you also get a 4 out. So it appears that as you get closer to 3 from the negative side, the y values that are coming out are getting closer to 4. And so that limit is 4. Okay, and then g, we're supposed to find the limit of g of x as x approaches 3 from the positive side. So if you approach it from the positive side, you're plugging in numbers in here. So for example, maybe you're plugging in 3.5. The y value that comes out is a little bit below 3, maybe 2.9 or something like that. And if you were going to get closer, like maybe 3.2, the y value that comes out is a little bit closer to 2. And in fact, if you plug in like 3.1, you get even closer to 2. So it appears to be, as you get closer to 3 from the positive side, as x gets closer to 3 from the positive side, the y values appear to be dropping down towards 2. And so that's why this limit is 2. Okay? And then h, find g evaluated at 4. So 4 is right here. If I plug a 4 in, the y value that comes out appears to be 3. So g of 4 is 3. And then the last one is we're supposed to find the limit as x approaches 4. And this is a two-sided limit because it doesn't have a superscript. So x equals 4 is right here, and we're supposed to approach it from both sides and see what we get from both sides. If it's the same number, then that's the limit. If the numbers are different, then it does not exist. So if you approach from the negative side of 4, you have to plug in numbers in here. So maybe you plug in a 3, and the y value that comes out appears to be 2. If I were to plug in 3.5, you can see that the y value gets a little closer to 3. And again, if I were to plug in like 3.9, it gets even closer to 3, closer and closer to 3. So the limit from the negative side of 4 appears to be 3. And if you were to approach from the positive side of 4, you might plug in, let's say, 4.5. The y value that comes out is right there, a little bit below 3. And if I get closer to 4, maybe 4.1, you can see the y value gets a little bit closer to 3. So it's also approaching 3. And so both the left side and the right side limit are approaching 3. So the two-sided limit would then be 3. Okay, and so that's part I. Okay, this two-sided limit as x approaches 4 is 3. Again, because the limit from the negative side of 4 was 3, and the limit from the positive side was 3 as well. So the two-sided limit would also be 3. Okay, I hope you found this video helpful, and I'll continue to work some of the homework problems from Chapter 2. Okay, bye-bye.